that Oz Minerals are putting out. So it's private data from one of their projects in South Australia called Mount Woods. Lots of data. Jess will go into that in way more detail about all the data, but essentially they've been working on this exploration project for around 10 years, spent quite a lot of money exploring. It's around the Prominent Hill mine, which is the copper gold mine. Lots of other mines in that region as well. But they have not found another economic deposit outside of Prominent Hill, open pit and underground in that area. So they're really interested to get other people looking at that data from a fresh perspective, some not just geologists as well, some other disciplines, to see what else can be unlocked from that data, and can you find Australia's next big deposit in that data set. So as you know, we're trying to get other people, not just geologists, to work on this, so we thought we'd have a bit of a fun introduction. What do I have to press?
I'll go back.
Data scientists think that domain experience is something to be ignored until you need something to blame for their model being crap.
How many of their exploration projects are successful?
Doing the same thing for I don't know how many years now, and the success rate has always been only about 1%. With data science, we can actually go way more accurate.
I like to be the smartest person in my group of friends, so naturally you think that I'd be friends with data scientists.
just go out and lick a bunch of rocks.
Yeah, we do lick rocks. It tastes pretty good. But it's seriously a diagnostic tool. So unless you're willing to put your tongue on the line and go out there and lick a rock, don't talk to me.
So as data scientists, we don't have to run into spiders, ants, snakes, mining engineers. That's pretty good.
The problem with data scientists is they tend to think inside their little square. How about you get outside the room, go out, walk in the bush, go kick some rocks, and try and find something?
The only way data scientists would recognize quartz is if someone gave them a necklace.
We can do as good a job as geologists do, but we just do it from home.
As much as time we spend indoors, we spend a lot of time outdoors too. We just don't have to stay outdoors 9 to 5.
Data science, kiss my ass no para. I mean, clearly geology is the schist.
Right, so that was a bit of fun, but yeah, we are trying to actually get geologists and data scientists to work together. Just a bit more about why geology and geoscience is an interesting problem a bit later, but essentially, yeah, the problem we're facing is, like one of our fellow data scientists said in the video, exploration has a very low success rate, way less than 1% actually. It's like 0.01%.
What's IOCG?
I know, like copper gold.
Type of deposit.
So what we were going to say to that was just a note on what we're looking for. So we can go into some more detail, but for the geologists in the room, the mine that is in kind of the centre of this project is an iron oxide copper gold mine. We're not just looking for that type of deposit. So also really just looking for other kind of base metals, so gold, copper, nickel, those kinds of deposits. But essentially the problem is exploration is really hard. We've got a lot of data. Is there stuff that we can find in that data that we haven't done so far?
Where's Prominent Hill?
South Australia.
We can talk about that.
Do you want me to?
Yeah, I can take it from here. Yeah, so hi everyone. I'm as Holly said, I'm a data scientist, but I actually started out as a geologist, so I've kind of seen both sides of the fence.
You like computers.
Yeah, I like computers. Yeah, trying to get too many shocks. And really, I guess what I wanted to try and convince you of this evening is that geology and geoscience is packed full of really, really juicy data science problems. Okay, and you all should go home and start having a Google about, what sort of data and what sort of problems we could start to get into. The real big challenge, I guess, from an exploration point of view is knowing where to go to find a deposit. So let's say I want to find gold in the Earth's surface. How do I actually take a sample here? Where do I put my geologist? Where do I send my geophysical survey team to best get the best data to be able to then find that deposit? And the big challenge is really that we have about 15 orders of magnitude in length scale in terms of variability that we're looking at in our geological data sets. So what I've got here on the right is an image of the magnetic field right across Australia. So this is collected by Geoscience Australia, which is the Federal Geological Survey. And then we can go all the way down to, this is a map that was collected by CSIRO. It's on an instrument called the Maya X-ray fluorescence mapper. And each pixel in there is 2 microns across. So you're looking at chemical variation, physical variation from that kind of crustal scale right down to that micro to nano scale. And you might say, well, maybe you could ignore some of those scales, but actually knowing exactly where the gold is in your rock at this level will determine often whether you've got an economic deposit or not. So there's a really, really big search space and a lot of really big unknowns within it. So what do we do at the moment? Basically, exploration geoscience is roughly around, well, it's basically trying to reduce the search space. So say I'm Oz Minerals, I'm working out of Adelaide, I might be trying to find a deposit in South Australia, so here's South Australia. This is a grab image, I think, of South Australia. And so I might have some land in the middle of South Australia, and this is actually where Prominent Hill is. It's sitting within that, it's actually sitting right here. But basically I'm now gone from a search space of all of South Australia to just the tenement that I care about. And what I'll do is I'll send a bunch of geologists out, I'll get them to map all of the rocks. I might send out some geophysical teams to take some high resolution geophysics over a bunch of target areas within my domain. And hopefully I get to the point where something looks like it's worth drilling. And so I get a nice little mag high or a grab high or something that says there's some dense material there and maybe that's a mineral deposit. So the key thing, I think, the first takeaway for you guys as data scientists or machine learners is there's a lot of opportunity within these workflows at all of these scales to be adding value from the data. At the moment, a lot of this interpretation, I mean, the geophysical inversions are done with inversion codes, but a lot of the interpretation is just some geologist taking another swig from the whiskey bottle and looking at this mag and saying, well, I think we should drill here. That's exactly what happened. And the key problem is that at the moment there's no feedback loops. So if, as a geologist I say we should drill here and I don't find anything, what have I learned? Well, I've learned, maybe we need to go back to the ASX and get some more money out of a few more gullible investors. Yeah, exactly. But there's a lot of opportunity, I think, to actually bring some data science rigor to this process of exploration and make it much, much more effective and efficient. Yep.
So, are you searching for gold?
Searching for any kind of base metal that might be in the deposit. So it could be copper, it could be anything. Basically, if you're an exploration company, you just want to find a resource that's going to make you money. You don't really care what it is. Typically, what ends up happening is because you've got that model sitting inside a geologist's head, the exploration company tends to look for a deposit of a particular type. But again, there's no reason why you should restrict yourself.
Don't close your mind off to that.
Yeah, exactly.
They are kind of looking for something that can be processed through their current plant though, so that's why ideally like similar types of commodities to what they already have. So if you found a lithium deposit, that would be really interesting, but they'd have to set up a whole new plant to deal with that.
Or lease the section.
Yeah.
Or lease the section.
Or lease it, yeah.
Yeah, exactly. Yeah.
That 1% you mentioned, how's that measured? Is that when the geologists have said, yes, there's definitely metal there, and then it isn't?
That's your stat, Holly.
I honestly don't know how they calculated it, but it would be around basically like for the number of,
Exploration.
projects,
Greenfield
drill
holes.
holes, which ones actually become something that's economic.
Sorry, over there.
Talked about difference in length scales, what about depth?
Well, I'm including depth as part of that, but yes, yeah, just length generally is an issue.
When you, I could imagine two kinds of success. One is you've convinced them to drill a hole, and the other one is they've actually drilled a hole and it was successful? I mean, do you win by having the most convincing argument that they will go and drill it because they're obviously going to spend a lot of money to go and drill a
That's
hole?
right. Well, this is the opportunity that's being offered here,
Yeah.
and
To
this,
convince.
Yeah.
So you've got to be convincing.
Yeah.
Yeah, it's not.
So we do literature review, and we come up with a criteria, or
Well, we'd like you to do a whole range of things. I think we're not trying to restrict it to a traditional sort of geological approach. We actually want to see. We're going to provide a whole bunch of data, which I'll get into in a minute, and we want you guys to do whatever you think is best with that data, and convince us that we should drill. Okay, I'll come back.
Yeah, you'll get
We'll
to
keep,
it.
we'll keep
Yeah,
moving.
sorry.
So I mean, this is really about what the challenge is. I mean, the big challenge is they've already got Prominent Hill, they've got Carapatina as well, and can you find something else in this area that they're actually going to drill for you? And they have committed to drill the top
No.
It's a top number of targets. I don't know what the actual.
Only within their tenement?
Yes, only
Only within the tenement. Yeah. So what data will we have available? We've got over 1 terabyte of exploration data, which has been the bane of my life for the last 2 months. And you can see some of the numbers there. We've got around 37,000 images of samples. There's about over 88,000 assay samples. A whole bunch of seismic, a whole bunch of lots of geophysics.
Undifferentiated
This is my crappy data classification first pass. Most of those undifferentiated bin files are actually associated with some of the geophysics. So if you happen to be a geophysics expert and you know how to process raw seismic, or you know how to process induced polarization or electromagnetic data, then that data is available for you to reprocess that. But we're also providing a lot of the processed products, so things coming out as raster images over the tenement, or basically things that you could take as a machine learner and plug into an algorithm to try and essentially take the whiskey drinking away from the geologist and give it.
So what about like geological lines and things?
Yep, it's all in there. Yep.
All in there.
Yep.
And they're
Absolutely.
basically giving everything that they're
Everything that they've got, they're
except
opening
for
up.
like, you know, consultant reports or stuff that they can't really give out. But everything that they've collected, they're giving.
Reminds me of the Gold Court challenge.
Yeah, yeah.
Exactly.
Which my company won.
Well,
Will you win this?
Fact.
Yeah, absolutely. So there's a whole bunch of basically anything you can measure about the rocks that they measure routinely. That's in that data set and will be available.
Is there any drill hole data?
Yep, absolutely. Yep. So hundreds of drill holes, all those assay samples, those 80,000 assays are all measured on the drill holes. 50 elements in that assay suite, so it's a really big dump of really quite juicy data to start having a play with. So, slide. So we don't want to just give you this big dump of data. We're trying to make it as easy for you as possible to get into it. I think someone mentioned the Gold Court challenge and the Integra ones, and a lot of those consisted of, hey guys, here's 5 terabytes of folders. Do what you like with it. We've actually done some initial work to try and scrape a bunch of metadata, a bunch of geospatial information out of this data, so you're able to go in there and search it. It means you're not having to download 2 terabytes of data at the start of a competition, even though 50% of that is seismic files you're never actually going to process. So we'll have a data portal available. We'll be able to either go into individual data sets and pull them out, so if you want to look at a particular drill hole and pull the photos for that hole, or just the assay data for that hole, you can do that. We're also going to try and provide like format specific dumps, so we'll just pile all the vector data into GeoJSON and dump that out. So if you just want to download 20 gigs of GeoJSON and munge that in some way, then you'll be able to do that as well. If you've got any suggestions as to how you would like to access that data, then I am around. We'd love to know what would work with your workflows. We want to make it as easy as possible for you guys to
So what is total size?
Total size is, at the moment, we're still going through the final release, but it's over 1 terabyte.
Over.
Yeah. But most of that is things like the raw seismic data. So the actual process data is probably a few hundred gigabytes. So it's downloadable.
Okay.
Yeah. there's a bunch of other stuff in there that we're doing, so you'll be able to search through and actually see the tables and what's defined in the tables and schemas sitting inside all the geospatial data. Keep clicking through. It's probably more interest to the geologists than the data scientists. You guys probably just want to go straight for the data dumps. So we'll try and make it, again, like I said, as easy as possible for you guys to be able to do that. If you want to get started now, there is a bunch of open file data which is produced by the state surveys. In particular, SARIG, which is part of the South Australian Geological Survey, have a huge amount of data sitting within their portal. It's not at the same resolution as the private data that's being released at the end of February, but it is really good if you're wanting to perhaps train a model on other deposits within South Australia that might look similar to things sitting inside the Mount Wood deposit. Next week, we haven't confirmed the timing, but next week SARIG will be giving a presentation on the data that they've got in there. There's a whole bunch of reports and again, lots of geospatial files, coverages, all of that sort of thing. And there's also a bunch of other government agencies that provide, remote sensing data or, geological data like Geoscience Australia that I mentioned earlier. National Map in particular is a really excellent source of geospatial or geological data to actually just start having a think about, what you might want to be building a model on the back of.
What is the national map?
Does everyone know what National Map is? Do you want to see National Map?
Yeah, you don't see a bit like.
Yeah, okay, so nationalmap.gov.au, it's a data portal which was built by Data61, and it scrapes all of the open data that's available from government and makes it all available to you in a map view. So you can basically sort of search through, find data sets you want, and if you actually want to then extract that data, there's a whole bunch of web services to help you do it. So that's another really good source. But look out, if you are signed up to our mailing list, we will tell you when and where and how to see what SARIG have to say next week. Okay, so Valentine's Day. We think that the winning result is not going to be a pure data science approach, and it's not going to be a pure geology approach. We think the winning teams that are going to be most convincing are going to be the ones that take a combination of approaches. And the real reason for this, speaking as someone who has sat on both sides of the fence, is I think when it comes down to it, data scientists, machine learners, and geologists think in fundamentally different ways. And that diversity is a really, really good thing if what you're actually trying to find is a deposit. And so this is my lumpers versus splitters diagram. And I guess what I would say is machine learning is really good at doing splitting, categorizing things, pulling out trends and things like that are little bits of your data. And geologists are really good at then taking that information and mushing it back and telling you what's really important about it. Okay. And the reason that we have to have geologists to mash some of this stuff back together is that it's not always clear from the data alone what it is we're actually looking for. So the number one thing about ore systems geology is that it's really freaky. Right? The rocks that form mineral deposits look nothing like most rocks on the surface of the planet. So that means if you're taking a pure data-driven approach to trying to learn about the geology and basically be able to then target where your deposits are, you're going to be training something that's mostly on here, but actually the thing you care about is way out here in the tail. And in fact, I mean, in geology, we don't know. We sort of play this game of trying to put different deposits into categories so we can try and guess where to find the next one, but we really don't know actually. So, so it is a real challenge. And I would also say, that because it's all in the tail here and it's these really, really rare events, it's actually really hard to find enough data points sometimes to train a model. So just coming back to this shot of South Australia here, what they've got, this was released as part of the PACE copper strategy. What they've got is essentially every drill hole that intersected a little bit of copper in South Australia. There's quite a lot of drill holes that have intersected some copper. But really, if what you're looking for is a deposit, you've probably only got 5 or 6. I mean, okay, yes, you've got Olympic Dam, biggest IOCG on the planet, makes BHP a lot of money. But you really only have a very, very few sort of number of training examples to play off. And the other thing I would say is that the priors are really important. So just because you can extract the trend from some chemical data, it may not be a geologically very interesting trend. So this is an example where I'm showing a ternary diagram. This is sort of like a composition of three different minerals. And it may well be that, for example, the dominant trend that you might pull out from some data might be just the regional metamorphism that's changing mineral A into mineral B. And we don't care about that, we know about that, right? What we actually care about is the little trend that pushes towards mineral C that maybe tells us something about there being a deposit within those rocks. Okay, but caveat being, for some commodities, for some situations, so there's always these edge cases, and because you're in the tail, the edge cases are always going to get you every time. So we think there's going to be a really important kind of back and forwards between data scientists and a friendly geologist who's going to be able to kind of look at it and go, yeah, this one makes sense. No, you've just found the metamorphic gradient and it's boring and we don't care about it.
And it's been better.
Absolutely. And I would say that if you can do it well, then it does pay off. So this is an example of a company that I think the Gold Spot. Was it the Gold
They
Spot?
they won the Integra. Well, they were winners of the Integra Gold Rush Challenge.
Yep.
They're called Gold Spot.
They're called Gold Spot.
Discoveries.
They're now a very, very fast-growing company based out of Vancouver in BC, involving a lot of data scientists and a lot of geologists. Got a lot of big investment from people in North America. So if you're really looking for a place to kind of springboard an approach that potentially you could build a business out of, it has been known to happen. So there is that as well.
And yeah, there's two kind of well-known examples that happened before, as you mentioned, where it just got a big data dump. So one was the Goldcorp challenge back in 2000 by Goldcorp, and then the Integra Gold Rush, which by Integra Mining in 2015. So this is the way we're teaching it a little bit differently, as all the work Jess has done in that like data prep side, whereas the other ones is just like, you go.
Yeah. A lot more geological focus. Cool. Can I go to this and then come back? Is that cool? Yeah, sweet. So I just want to, if you're not familiar with geological data and you're not familiar with the sorts of data sets that I've been talking about, the sorts of geophysical stuff, we do have a geological prediction challenge with trainer wheels. So this is my drill rig with the nice pink trainer wheels on it, where we're going to run a live leaderboard classification competition in the first 5 weeks of the competition. So you'll be able to actually start building some models and getting feedback on how well that's doing. That will be based on public data from around Australia for a range of different metal types. And we're really going to be looking for how well you can predict whether there is a deposit at the centre of a little square of a whole bunch of different layers of data. So that will be running for the first 5 weeks. And the idea is that you can use this as a chance to just dip your feet in the water. There is, I'm not sure how much prize money we're putting towards that one.
30, 15, 5.
30, 15 and 5. So 30k, 15k, 5k prize just for that data science competition on that data science stream. So it's probably worth entering just by itself. But what we'd like to see you do is basically dip your toe in the water, work out what some of the problems are, and then hopefully reuse those models in the main competition where the big prize money is up for grabs.
So you show on the previous picture that there's some success stories in Canada. Some companies already use the technique and they use the data to locate the reservoir.
They do.
Why you're not asking them to do the job? So what's the point of competition? I don't get it.
They charge more than $1 million.
Yeah.
I think, do you want to answer this?
No, you go. You go.
I think, at the moment, using machine learning in mineral exploration is an emerging field. It's not like we have great machine learning. This company doesn't have a one-use machine learning model that can just find you whatever deposit you want. It doesn't work like that. So it's a really emerging field, and a lot of what Jess was saying around that, it's really rare. It means that it's really hard to actually apply some triple machine learning techniques to it. So there's many companies similar to this one actually. And you find that there's quite a lot of consultants doing that work. So there are more people coming into that field, but it's still open. And so it's still worth having a competition to find people with different skills, different approaches that can bring those different domains together and think of it in a different way. Otherwise, if this was a silver bullet, then the whole industry would have already changed.
So I still don't get it. If the point is to find the actual location of the gold, and they already have a software or machine learning system.
They don't. They have a slightly less manual process than what other people
Yeah,
do.
so I guess, okay, so geologists here, so I just want to point out, so different continents have different geological styles.
Yeah.
So what works in North America doesn't necessarily mean it'll work in Australia, just because of different geology, different ages of rocks, etc. So that's why you can create a model like just for Canada, but they can't bring it here because it's just not going to work. Does that
And-
answer your question?
Not clearly, because I basically, if I'm that company, if I come to this $1 million competition, I'll put my team in it.
Oh, so your question is like, why are these guys?
Yeah, they're not giving the job to them.
Well, because it's not like they're definitely going to have the right answer. There's potentially many other approaches that could potentially come up with something better. As Hilary was saying, like
Are they involved in this competition as well or not?
probably.
Probably
I don't know,
compete
maybe.
if they think
And
they have
at
a
the
good
end of
model.
it, whoever comes with the software, does the software belong to the developer or to you?
The developer.
Yeah.
We can,
So if you get to it first,
yeah. But it's just a hard problem, right? Like it's not like someone's going to just come up with a perfect solution that's going to be able to find things around the world.
So if the kind of main competition is not based on ground truth, how is it going to be judged?
So we'll have a judging panel combined of geologists and data scientists, 50-50. So it'll be really around like essentially technical rigor, the way you've been able to describe your methodology and back up your reasoning essentially.
Is
So
that a pitch or like document as
both, so we're asking a 5-minute kind of video pitch just as a quick way of kind of explaining what you're doing, and then a kind of technical report as well.
just leading from that, how does that work with given that like the current latest models in deep learning aren't necessarily super explainable, right? Will that be kind of taken into account or
Yeah, I mean, I think that's why we've got data science expertise as well in the judging. Is we want you to explain, if you've used a deep learning model, tell us how you've used it, what sort of method you've used, how you've sort of treated the data to make it more useful, and why you think this is the most accurate model that's there. Okay, and we take that into account when we're judging as well.
I reckon it would be fair to say you don't have to explain what the network is doing. You have to explain why you think that network is the right network, and what it was optimizing is the right thing to optimize.
Exactly.
Alright, okay. So a bit more information around what is actually happening. So the competition goes live on the 28th of February. On the 22nd of Feb, we'll launch formal kind of registration, so terms and conditions, the forum will be live. There'll be a bit more information available on the website, so that's next Thursday. But yeah, data will be available from the 28th of Feb. The competition is going to be running approximately for 2.5 months, maybe extended. But at the moment we've got submission deadlines as the 10th of May. And then we haven't got the final announcement date exactly, but that will be sometime in June. And then the testing of the targets will be done in that second half of the year by Oz. So the prizes and everything is not awarded based on the drilling, it's awarded based on the submission. So that will happen in the first half, but definitely Oz are keen to show that they're testing those models and what the outcomes are. So yeah, a bit more on the judging and submission. So as we kind of said, we're asking people to submit a 5-minute video pitch, just because video is a nice easy way of just talking, getting across your ideas and thoughts about something, and a more detailed technical report. Plus a digital model. Now what we mean by a digital model is essentially just a prospectivity map. So we're going to ask for geotiff, which kind of essentially, we'll have more details on there, but it's basically a probability of where you're saying that ore is going to occur. We'll also ask kind of a basic CSV of just your top number of targets and their size, their location, that kind of thing.
So that's a 2D. You're not really talking about depth and worrying about the viability of open cut versus underground and things like that.
Well, the prospectivity map will be 2D, but the top targets we're asking for that 3D, so X, Y, and Z coordinates, so that we can get that depth.
Remember, you're trying to convince as well. So
Yeah.
if you can show that you've taken that into account, then great.
Yeah.
So definitely around this area, a lot of the basement rock where we're expecting mineralization to occur is under some cover. So taking into account that depth is important because it's likely that it's going to be something that isn't a surface expression. So yeah, as we said, there'll be a combination of geologists and data science on the judging panel. In terms of the prizes, there's actually quite a few categories which we'll announce on the 22nd next week. So it's not $1 million for one person. It's going to be $500,000 for the first prize and tiered pricing throughout that. And there's also going to be some specific smaller data science focused challenges around how you're using the data in different ways. So there is kind of a spread of challenges. So there's lots of people, lots of opportunities for lots of groups. Anything else on the judging? Yeah, so I think that's pretty much it. Interested to hear, I guess, your thoughts, if you have any more questions, any kind of initial thoughts of if it's feasible.
I have a question just on the sort of judging methodology relating to whether, you know, in there's like the adversarial court system and the inquisitorial system. I don't know if you know about that, but one is the judge just sits there and you present your evidence and they're not allowed to try and delve into it. And the inquisitorial is the judge is allowed to ask leading questions and try and. Is there going to be like a dialogue, or is it just like based on your submission and there's no like? Because I feel like the inquisitorial approach is better in the sense that if you don't have great presentation, but you've got great data science, the judges may be able to draw that out of you by asking questions and having a bit of back and forth.